Hello, so we're going to go over in this video the unit circle. Right? Now the unit circle, as we see here, called because its radius is of 1 unit. Now the Cartesian equation or xy equation is this: x squared plus y squared equals to 1. Right? General equation of a circle. It's not a function, it's a relation. And since we relate the values of x and y, we take x squared plus y squared, and that's equal to the radius squared. In this case, the radius being 1, 1 squared is 1. All right. Now, in terms of our Cartesian coordinates, that's how we generate equations, right? It's a way to relate the x and y in some point in space. Now, trigonometry aims to kind of change that, or change the way you view that, and instead focus on an angle in standard position, how we can relate a point in space here. But we'll get to that eventually, right? The goal here of this video is to introduce us to the unit circle and plot out some special points on this unit circle. We're going to start off with what are called quadrantal angles, right? In other words, angles that lie on the axes, in this case, the x, y, both positive and negative. If we think of an angle in standard position, right, this is our terminal side here, our initial side, I should say. Right, and then we sweep at a positive angle, right? We'll focus on positive angles for now, in the counterclockwise direction. Okay, so this would correspond if this was both the initial and the terminal side, right? That corresponds, the Cartesian coordinates are the terms 1, 0, right? But that also corresponds, let me zoom in here, right, to an angle of 0 radians. Okay, now as I move, and actually, don't want to clutter this too much here. Let's say 0 radians. Now as we sweep out, let's look at the next quadrantal angle here. That would be, remember, these are two perpendicular axes. So this would be 90 degrees or pi over 2 radians. All right, and the coordinate here would be 0, 1. Okay, again, x, y coordinates. Now as I continue going, I'll go to the next axis, another 90 degrees. Leaves me at this point here, with that point being negative 1, 0. Right? And that point corresponds to a radian measure of pi radians. And as I sweep going another pi over 2 radians, that leaves me at 3 pi over 2 down here, with coordinates of 0, negative 1. Okay, and those are our quadrantal angles. All right, now we're also going to take advantage here of identifying special points in here. Right, and those special points are going to come from our special triangles. Right? So let's say our first special point, we're going to look at 30 degrees, which is equivalent to pi over 6 radians. So here I'm just going to 30 degrees. All right, so that's pi over 6 radians in this case, and again, that is the angle here, right? Pi over 6. Okay, now, if we recall from our special triangles, if this is 30, this is 60, well, I should already know what the lengths of the sides are. All right, if this is our 30 degrees, right, that means that this one over here is going to be root 3 over 2, right, our x coordinate. And our y coordinate is going to be 1/2. And that comes again from our 30, 60, 90 triangle. Our next special angle along this is 45 degrees or pi over 4. And we'll do that. That's around here. Change colors here. So that is pi over 4. And again, that is that angle swept up over here, which is 45 degrees. And again, these values come from our special triangle, 45, 45, 90. And now the nice thing about this one is here, both of the sides are the same, and that being root 2 over 2. Okay. All right. So moving along here, we have root 2 over 2. Our next special angle is at 60 degrees. And 60 degrees. Right about here. And again, 60 degrees being pi over 3. All right. And 60 degrees also being this angle being swept up over here. Now we just kind of flipped the triangle, the 30, 60, 90 triangle here, right, well, on its side here. So all that means is that now in this case, the x-coordinate is 1/2, and the y-coordinate is root 3 over 2. Okay. All right, and that gives us our special points here on the unit circle. All right, now another thing here is we're going to find these other points on the rest of this unit circle. And the way I'm going to do that for now, I won't assign them angle values. We'll do that a little later when we talk about reference angles. But I'm strictly going to use the symmetry of the unit circle, right? What I mean by that is, notice if we have our unit circle here, if I fold the unit circle along either the x or the y-axis, right, if it got folded along here, it's like a mirror image of it along either the x or the y, right, if I fold along that axis. So that's helpful because now I know other points here on this axis, on this unit circle, I mean. All right, so what I mean by that is, let's say, for instance, here, this point down here is a reflection of 1/2 root 3 over 2. So all I have to figure out here is, okay, well, on this quadrant, the fourth quadrant, the x-coordinate is still positive, but now I'm below the y-axis. So the y-coordinate is negative. Right? And it's symmetrical, so I know the values. I just really need to change the positive or the negative. Now, in the same manner, that means, okay, well, how about this pi over 4 point here, root 2 over 2. If I continue this down here, right, this point down here, x-coordinate still positive. The thing that changes here is the y-coordinate, right, and it changes sign. Right, and the same way down here. Right, I go to this point here. Right, the reflection of this point, still a positive x value, but now we have a negative y value. Okay. All right. Okay. And if I go along here with these, the ones reflected across the the y-axis, this point here. Now in this case, what changes, we're now in the positive, still in the positive y-axis, but now we moved over to the negative x-axis. Alright, so each of these points here gets a change in sign for the x-coordinate. Okay. And then lastly, when we go down to our coordinate here, this quadrant, excuse me. Now in this case, we're in the negative x and the negative y-axis. Right, so they both get a negative sign attached to them. Okay, and these are the special points on our unit circle.